Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Well fellas, now we gonna solve question 11 of this question paper. Well, let's get started. Which of these compounds cannot form an amide in a reaction with ethanol chloride? Okay, so the question says about the compounds cannot form an amide in a reaction with ethanol chloride. So what does amide means? Amide actually means this compound, this particular compound, CON. Which compound has this particular group, CONH? Okay, so this is amide. Don't confuse with amine. Amine is this one and amide is this one. Okay, so amide is this one, CONH. Okay, so which compounds cannot form an amide in a reaction with ethanol chloride? So ethanol chloride, okay, let's discuss what type of chloride is this. What type of chloride? It's ethanol chloride. So on other words, we can say that it is acyl chloride. Acyl, not acyl, it's acyl chloride. Okay, it's not acyl, it's acyl, ucyl, no, acyl chloride. Okay, fine. So this is acyl chloride. So what type of chloride is this? This is acyl chloride. Okay, so here amine is okay, this is what type of amine? This is ammonia. Okay, this is not amine, this is ammonia. Okay, so here ammonia gives amide. Ammonia gives the amides when it reacts with acyl chloride. So ammonia reacts with acyl chloride to give amide. Okay, so here this compound, this amine compound, it also gives amides. Okay, amides, this also gives amides. But this doesn't give amines. Doesn't. Okay, doesn't give any amide. Such a poor guy, it doesn't give any amide. You such a miser. Not you, this guy over here is a miser. It doesn't give any amide. These three are good. Okay, they are okay giving amides, but this doesn't give any amides. Why? Let's see. Okay, so in here we have this nitrogen attached to 3 hydrogen. Okay, in here this particular hydrogen will react with acyl chloride to give amide. So in here we gonna get amides by eliminating hydrogen from the ammonia. Okay, so we're gonna get amides by eliminating hydrogen on this particular ammonia. So that is why ammonia gives amide. Since it has 3 hydrogen, it can give 1 hydrogen, it can give off 1 hydrogen to give ethanol chloride while reacting with acyl chloride. Okay, so let's see about B. So in here we can see that this particular nitrogen over here has 2 hydrogen. So in here it has 1 alkyl group CH3 and 2 hydrogen. So in here we also know that this is what type of amine? 1 degree amine. So here it is 1 degree amine. So from 1 degree amine we can see that in 1 degree amine nitrogen has 2 hydrogens. So nitrogen is happy to give off hydrogen while reacting with acyl chloride to give ethanol chloride. Okay, so when this amine, this 1 degree amine reacts with ethanol chloride, will give off 1 hydrogen forming an amide. Okay, so that is how it goes. So in here let's see over here this particular ammonia, this particular nitrogen in this amine, this is 2-degree amine or primary amine. Okay, since this amine has one hydrogen on this particular nitrogen. Okay, so in here this nitrogen has, since this nitrogen has one hydrogen attached to this nitrogen, so we gonna call this 2-degree amine. Okay, since this this nitrogen guy over here has one hydrogen, still this nitrogen has one nitrogen, still this nitrogen has one hydrogen, so it can give one hydrogen while reacting with ethanol chloride to give amide. So that is why it will react with ethanol chloride since it has one hydrogen. So okay, I'm gonna discuss this on the whiteboard, no, don't worry, but for the time being just notice that this nitrogen has one hydrogen over here, so that is why 2-degree amine reacts with ethanol chloride to give amides. Okay, so in here this guy over here, this nitrogen guy over here have no hydrogen. Instead it has two, what should I say, alkyl group. So this nitrogen has 3 alkyl groups attached to this, doesn't have any hydrogen, poor guy, so it won't react with ethanol chloride or acyl chloride to give amides. Okay, so now let's move on to the whiteboard and discuss in details about the scenario that happens over here. Okay, at first let us draw the nitrogen compounds. So our first nitrogen compound is ammonia. Okay, let's just don't write like this, let's write it in different manner, different fashion. Okay, so let's draw like this. Displayed formula, and it has one lone pair. Okay, lone pair of electrons. So in here, when this particular ammonia reacts with ethanol chloride, this chloride, H3C CCl. Okay, CH2Cl. Fine. Okay, so when this ammonia reacts with this ethanol chloride, this particular hydrogen reacts with which one? It gonna react with this chlorine. Okay, let's just introduce the chlorine over here. Okay, let's just draw the chlorine over here. Okay, this is chlorine. Fine, and this is CH3. So this is ethanol chloride. So this particular hydrogen over this nitrogen, it gonna react with this chlorine, eliminating this one, and we gonna have what? Amide. We gonna get amide. We gonna get amide by eliminating hydrogen H from NH3. Okay, so that is why ammonia can react with this ethanol chloride, since it has 3 hydrogens, so it can give one of its hydrogen to ethanol chloride to give amide. Okay, so here, so by the way, let's see what does this amide looks like. Okay, I don't want to draw this in details, but let's discuss how does amide look like. Amide has this functional group CONH. Okay, so we're gonna find amide like this. So amide has functional group as CONH. Okay, so now let's move on to the next one, which is CH3 and H2. Okay, so it's again gonna react again this hydrogen will gonna react with this chlorine on this ethanol chloride to give off HCl, forming an amide. Okay, same as before. Since this amine has 2 hydrogen, or since this is 2-degree amine, this is ammonia. Okay, this is ammonia and this is amine, 1-degree amine, 1-degree amines. Okay, so here 1-degree amine has 2 hydrogen on this nitrogen atom, so nitrogen can give off hydrogen while reacting with ethanol chloride to give amides, forming amides. Okay, just like before, amide by eliminating hydrogen from this compound, just as before, same as before. Okay, so now let's move on to the next option. Okay, next option is CH3 CH2 and H. No, I don't want to draw like this. We have different style, we fellas have different style of drawing. Yeah, that's the spirit. So this is CH3 and this nitrogen gonna have H. Okay, so this particular hydrogen will gonna react with this Cl on this CH2 CH3. Okay, forming an amide, just like this. Okay, since this amine is 3-degree, sorry, I'm extremely sorry, fellas. No, not this one. This is 2-degree. Okay, heck no, this is 2-degree amine. Happy? Yeah, I'm happy. So here since this is 2-degree amine and this amine, this particular nitrogen has 1 hydrogen left to react with ethanol chloride, so it gonna react with this ethanol chloride because this has 1 hydrogen left. Okay, so that is why it gonna react with ethanol chloride to give amides. Okay, just like before, giving amides by elimination of hydrogen from 2-degree amine. Okay, now let's move on to 3-degree amine. What happens to 3-degree amines and why 3-degree amines don't form amides? Let's see why. So if we draw the structure of 3-degree amide, so we're gonna end up like this. Okay, this let's just draw the nitrogen atom over here, and this nitrogen guy over here has 2 methyl group attached to this thing. Okay, CH3, and here CH2 mistake everywhere. Human makes mistake. No, not 3, CH2. What am I doing? I have gone mad, fellas. What should I do? Okay, this is CH2 and this is H3C. Okay, fine. So in here, okay, let's not draw like this, let's draw in a different fashion, since we have different fashion. Okay, so here it is CH3. So here if we see that, so this is another part, don't want to mess this one with the previous part. Okay, so this is totally the other part. Okay, so in here we can see that this particular nitrogen atom over here have no hydrogen atom to give while reacting with ethanol chloride. So it doesn't react with ethanol chloride. Why? That's because because this nitrogen has no hydrogen atom, so it won't gonna react with ethanol chloride. Okay, so it won't gonna react. Don't make mistake, the time is short. Oh, what happened? Hurry up. Okay, I'm just hurrying up, just give me little time. Okay, okay fellas, okay, that's fine. So this was what? Ethanol chloride. Okay, so since this nitrogen guy over here doesn't have any hydrogen to give, so this ethanol chloride won't react with the 3-degree amines. Okay, since this 3-degree amine is poor, it doesn't have any expensive hydrogen atom to give to ethanol chloride, so ethanol chloride won't get married to this guy. Okay, she is a bad toot, bad girl. I should be family friendly like Felix. Yeah, family friendly content. Okay, so she is a bad lady, so why she is not married to this 3-degree amines? That's because amine doesn't have any, this particular amines doesn't have any hydrogen. Yeah, so since this is 3-degree amines, so since these 3-degree amines, so this particular nitrogen over here has no hydrogen atom attached to this nitrogen, so it won't react with this bad ethanol chloride lady. Okay, so that's the reason why 3-degree amines don't react with ethanol chloride or acyl chloride. Yeah, have you got it now? Yeah, that's really good. I'm really happy that you have understood. Congratulations fellas, by the way. Okay, so fellas, that's the solution to this question. Now let's move on to the question. Now let's write the answer. Let's write the final answer to this question. So in here, the answer is D. Okay, so the answer is D. So the answer is D. Why? Because this is, first of all, this is 3-degree amine. The option D is 3-degree amine. Okay, and 3-degree amine doesn't have any hydrogen, okay, on the nitrogen atom, second of all, and third of all, it won't react with acyl chloride. That's the answer. So fellas, I hope that you have understood the question as well as the solution. So if you still have any confusion regarding this topic, please let me know in the comment below. I'm always happy to help you out. Okay, well, we are not done yet. I have something to give you fellas, special. Okay, so fellas, thanks for watching. It means a lot to me fellas, you stick till the end, so I really appreciate that fellas. I'm really happy that you have watched the whole video. So fellas, congrats fellas, we have made it till the end. Help us improve our lessons by giving your feedback. Okay, so you may give it either a like or dislike, both of them will do. So if you if you can give 100 likes, let's see. If you can give 100 likes, that would be okay, or you can give 100 dislikes. Okay, so if you can't give 100 likes, at least give 100 dislikes. Okay, so 1 like for each fellas or 1 dislike for each fellas. Okay, that we can do. So at least fellas give a dislike if you don't like this video, don't leave it blank. Okay, so if you are watching this, please either give it a like if you find it helpful, or give a dislike if you find it a complete trash. It's up to you. Okay fellas, so fellas, if you have any question regarding the topic, regarding the solution, don't forget to mention them on the comments. Okay, the comment, please leave a comment, and we really appreciate a comment for this video. Okay, it's really help us for the feedbacks, for making new video in the future. Okay, so here are the similar solutions like this one. So if you find this video solution helpful, if you find this solution helpful, you may find the previous solution of this question paper over here. Okay, we're gonna provide this on the playlist, and you can watch them by clicking it here, so you won't miss any episode. You're not missing any episode, okay, of this solution. So if you find this solution helpful, please watch the previous solution of this question paper over here. I'm gonna provide whole solution over here. Okay, so fellas, if you are already our fellas, we really appreciate that. So if you are not, if you are new to our channel, don't forget to click here. You may click here. Right, okay, you may click here to stay updated. Okay, click here to stay updated. We will be uploading solution of the question paper sooner. Okay, so you may click here to